This video is about applying ratios formed by parallel lines and identifying similar figures with overlapping triangles. So, first thing we're going to talk about is the side splitter theorem. So in the side splitter theorem, if a line is parallel to one side of the triangle and it intersects the other two sides, then it divides those sides proportionally. So if we have BD is parallel to AE, then we can say that the two pieces formed by it, so CB over BA, has to be equal to CD over DE. Now, that does not mean the pieces are equal, that just means that their ratio is going to reduce to the same thing. It does not work, though, if your variable is on the parallel side. So if we have a variable on BD and AE, we can't use a side splitter. We have to do what we did in class the day before. So solve for the missing variable. So number one, we're going to solve for x. All of our variables are on the side and not on the parallel side, so we can set up side splitter. So we would have x over 12 equals 15 over 18. So when we cross multiply, we would get 18x equals 180, x equal to 10. So just a faster way of doing the problems compared to yesterday, because in yesterday we would have had to do the entire length of both sides. So this side would have been x plus 12, and this side would have been 15 plus 18, which would have been 33. So if I was solving like we did yesterday, we would have had x over x plus 12 equals 15 over 33. When we cross multiply, we would have had 33x equals 15 times x plus 12. 33x equals 15x plus 180. Subtract 15, so we get 18x equals 180. X is still 10. So either method works, but using the math in the red with side splitter, it's going to go faster. Now, in number 2, we have variables on the parallel side, so we cannot do side splitter. So this time, I need the side from the smaller triangle, which would be 5, over the side from the whole triangle, which is 15, equals the first parallel side of the smaller triangle, which is 7, over the parallel side of the bigger triangle, which is y plus 1. So when we cross multiply, we would have 5 times parenthesis y plus 1 equals 15 times 7, which is 105. So we have 5y plus 5 equals 105. We can subtract 5 from both sides. 5y equals 100. So y is 20.
So in number 3, we want to find x and y. So again, we have our overlapping triangles. When we're solving for x with the overlapping triangles, we can use side splitter because we have x and plus 5 and 6 on the CA side, and on CD we have 9 and 15. It's being split by BD proportionally. So we would have 6 over x plus 5 equals 9 over 15. As we cross multiply, 9 times x plus 5 equals 6 times 15. 9x plus 45 is equal to 90. We can subtract 45 from both sides, so 9x equals 45. When we divide, x is 5. So in this case, it's okay to use side splitter for x. Now, when we're solving for y, because it's on those third sides, the bases of the triangle, we're not able to use side splitter. So we're going to use 15 over y, but now I need to use the entire side. So if I look at CE, because it has all the numbers, I know the smaller triangle has a side length of 9, and when I add 9 plus 15, I get a total side length of 24. So when we cross multiply, we get 9x equals 15 times 24. So when we multiply, 9x equals 360, and when we divide, we get x is 40. So we can't use side splitter when we're solving for y because of the numbers on the bases of those triangles. In number 4, complete each proportion with the correct segment. So Given that we have the overlapping triangles here, we have our smaller triangle with our larger triangle inside. If it helps you to visualize, you can also redraw these triangles. So the inner triangle is IGH, and the larger outer triangle is SGT. So if we are looking here, we see that we have GI over IS equals blank over HT. So in this case, it's using side splitter, so we would have GH as the missing segment. In B, we have GH, and then we have IH over TS. So because we are using the bases of the triangle, GH is going to have to be over that whole side of the larger triangle, so we need this whole side, which is GT. In our next, we have GI over GS is equal to GH, so we would need the whole other side, which would be GT. In our last one, we have IH over ST equals blank over GS. So GS is the whole side. The side from the smaller triangle is GI.
More general with side splitter, and we can use it for parallel lines. If 3 or more parallel lines are cut by 2 transversals, then those two transversals are divided proportionally. Now, there's a couple of different proportions we can set up. We can do side splitter, so we can say AB is equal to D over E, or we can do a piece and the whole length. So we could also do AC is equal to D over F, or BC is equal to E over F. It's just going to depend on what variables and numbers you have there to solve. So let's look at a couple examples. Number 3, we have 4 sections here, so each section that's on the same side of the transversal is going to be in a ratio together. So we have 5x plus 1 over 12 is equal to x plus 6 over 14. So when we cross multiply, we would have 14 parenthesis 5x plus 1 equals 12 parenthesis x plus 6. So we have to distribute our numbers, so 14 times 5 is 70x plus 14 is equal to 12x plus 72. So we're going to get x's to one side, so 70 minus 12x would get me 58x. And we're going to subtract 14 from both sides, so 72 minus 14 is also 58, so x would equal 1. In number 4, we need to solve for x, y, and z. So first thing I'm going to do is I'm going to solve for x, because I know that if these 4 sections will help me solve for x. So if this whole side is 32 and part of it's 20, we can subtract to get 12. So when I'm solving for x, I would have 12 over 20 equals x over 16. So when we cross multiply, we get 20x is equal to 192. So when we divide by 20, we get that x is 9.6. Then we can solve for y using the bottom 4 sections. So we would have 20 over y plus 15 is equal to 16 over 14. So when we cross multiply, 16 times y plus 15 equals 20 times 14, which is 280. We can subtract, or we can distribute the 16 to both things with parentheses, so 16y plus 240 is equal to 280. We can subtract 240 from both sides, so 16y equals 40. So y is 2.5. Then because we know that x is, we can use the top 4 sections to solve for z. So we would have z plus 5 over 12 is equal to z plus 3 over 9.6. So when we cross multiply, we have 9.6 times z plus 5 equals 12 times z plus 3. So we can distribute, and we would have 9.6z plus 48 is equal to 12z plus 36. So we can subtract 36 to both sides to get 12, and we can subtract 9.6 from both sides, and we get 2.4x. So when we divide 12 divided by 2.4, we get x, or we get z is 5.
So in number 7, we want to solve for x and y. So in this triangle, we have overlapping triangles. When we are solving for x, we are able to use side splitter. So when we're going to solve for x, we would have 12 over 4 is equal to 5x minus 7 over 6. As we cross multiply then, 12 times 6 is equal to 4 times 5x minus 7. So as we multiply here, 72 is equal to 20x minus 28. We can add 28 to both sides. So we get 100 is equal to 20x. When we divide by 20, we get x is 5. When we go to solve for y here, though, we're not able to use side splitter because 24 and 3y plus 2 are on the bases of the triangle. So we would have 24 over 3y plus 2 equals the side length from the smaller triangle, which is 12, over the whole side length, 12 plus 4, which is 16. So when we cross multiply, 12 times 3y plus 2 is equal to 24 times 16. So we get 36y plus 24 is equal to 384. When we subtract 24 from both sides, 36y is equal to 360. When we divide, y is 10. In number 8, we want to solve for x, y, and z. So in the first part here, with x, we see we have these 4 sections that have numbers on them. So we can use side splitter. So we have x plus 2 over 4 equals 7 over 8. When we cross multiply here, we get 8 times x plus 2 equals 28. 8x plus 16 equals 28. 8x is equal to 12. So when we divide, we get 1.5 for x. Then to solve for y, we can use the 4 sections at the top. Even though DF doesn't have a length, we know that this whole section between DH is 19 and part of it's 7, so 19 minus 7 would get us 12. So we can set up 2 over 6 is equal to y plus 17 over 12. So when we cross multiply, 6 times 6y plus 17 is equal to 2 times 12. 6y plus 102 is equal to 24. So we can subtract 102 from 24. And we get 6y is equal to negative 78. When we divide by 6, y is negative 13, which is okay because that would make that a positive length. Then to find z, we can call this missing length here w. So we have 4 over 9 is equal to 8 over w. When we cross multiply, we get 4w is equal to 9 times 8. So 4w equals 72. We divide by 4, w is 18. So then to get z, we can do 18 plus 8. So z is 26.